asked me to share a little bit about myself and my journey. As you can see at the moment, I am busy with Ohana. I'm the co-founder and the chief product officer at Hana. But I thought it'd be good to, she mentioned share some tips and tricks that I can share with you about my journey so far, if it's helpful for you guys. So I've tried to capture this. Couple of things about me. So let's get going. First off, there might be many of you who are moms out there. I am a mom of two, 4 and a 6-year-old, pretty amazing kids that I learn from every day. In fact, my son teaches me lessons often about superpowers. And he said, there's one that's called willpower. So, it's good to keep these things in perspective as you work through your own journey through your career. I'm an immigrant. I came here for grad school. I was looking up. I'm from Mumbai, India. I was looking up pictures, and the city did not look like nice like that when I was growing up back then. I came here for school to UC San Diego. And I started off at the database lab at that point. And so at heart, I'm a girl data geek. I was glad to be born with initials DB, database, and I've stayed within the data space since that point. It's been since the database days, the database lab days in UC San Diego. I've kind of stayed within the data space, databases, distributed data systems, etc. And so the 15 years of depth in a specific space have helped me a lot over time, because I have it's given me perspectives about different areas within data, different systems, which is is helping me in my career and my work today at Ohana. I started off my career at IBM, DB2 distributed kernel. Initially, I was in the storage and indexing teams. Over time, I moved to manage the data warehouse teams, some semi-structured, structured, semi-structured data. As I've kind of grown through my career, being deeply technical and hands-on, at every point has been a big advantage. In fact, I would say that it's been a bigger and bigger advantage. So don't lose that along the way. Stay technical, even if you become a manager, grow up through the ranks. It's a huge advantage over time. From that point, I wanted to do more on the outward in-facing side. And so I got my MBA at Haas, and I started to learn about being a product fanatic. How do you improve products? What does it take to make a successful product? It's taken obviously many years, and I'm still learning. Funnily enough, I've apparently learned that it can be a huge in deep tech, might be a disadvantage to actually have an MBA, because it's like you've gone on the dark side of from tech. But it did teach me a lot of things. Listening to customers, getting customer feedback, it's a gift. And so always be listening, whether you're an engineer, product, always be listening kind of to the inside out view. Don't just, be looking at cool, shiny stuff to build, but tech that solves some meaningful, real problems. Over time, I've become a team builder. I had that opportunity at Couchbase. I started pretty early on there at 25 people. When I started there, I actually hadn't had the chance to build teams from scratch. And I had the chance to do that not once, not twice, 3 times at Couchbase across different teams, the product team, the solution engineering team, as well as the product marketing team. And so inherently, now I like to talk to people, understand where they fit in, surround myself with really, really, really smart people that I can learn from and build successful teams, high performance teams. I'm really passionate about that. From that point, it also introduced me to open source. And Couchbase was the first technology. I did a little bit of it at IBM, but it was the first technology to bring me into into the open source space. And my current favorite project is Presto. We'll talk a little bit about that in a bit, so I won't steal my own thunder. In addition to keep it going, and maybe if I need a secondary profession at some point in time, I'm into mixology. It's things you should, beyond work, beyond family, that you need to get engaged in. And I'd recommend, finding something outside of work, outside of family, that keeps you going. All of that kind of coming together at Ohana, where I've founded the company with a good friend of mine, and someone I've known for 10 years. It's just the beginnings, but it's hope for a great journey. I do want to share that about 18 months ago, there was a point, there was a moment where I was at an event. It was the Gartner event with top 25 CIOs and chief architects in the Fortune 100, right? I happened to be accompanying a speaker. It was 2-day event, amazing experience, lots of networking, meet and greets, brainstorms, etc. Everything was great except the lack of representation. I was the only woman in the room, and so at that point, I was, it was just a moment where I said, things need to change. Either I need to do something about it, working with groups like Women in Big Data, or just taking the jump myself to dive into something more meaningful. So here I am, folks, talking to an amazing group of women and men. So that's a little bit about me, Shala. Since you had asked me to share, honored to be here. Thanks for inviting me. Any questions from you, Shala, or anyone else? Otherwise, we'll get right to the content.
I just want to thank you. That was really nice introduction, and showing your journey and your interest, really, to help, other women and being engaged. So we love for you to be even more engaged with women in big data, and we can definitely, benefit from your, experience and what you're doing, with your career moving forward. And that would be really great for us if we can discuss, further.
Absolutely.
Yes.
Absolutely.
Yes.
Happy
but I'd like
help
to see if
and...
anyone else, sorry about that. I want to make sure, if anyone else has any question for you, so I won't hog the conversation.
All right. We need an icebreaker question.
Yeah, we have a quiet team here, so that's okay.
No worries.
I like that mixologist. Sorry, when you put that pictures there, mixologist, I was thinking of, oh boy, I'm gonna get my margarita.
Yes, it's a little early in the day, but at some point. Yes. So thanks, Shala, for having me here. Let's dive into the content and get to the agenda. So I wanted to talk about a few about Presto, obviously. A little bit about the history of federation and introduction to Presto. We'll take a look at the architecture, why Presto is different from some of the other engines, and a little bit about life of a query. What does it look like through Presto? For those of you who are familiar with relational databases, some of it will look very similar. The query aspects of it. But the system aspects of it, the architectural, the federation aspects of it are different. And so looking forward to the questions you might have. All right, so federation in general is not a new concept. It's been around for several, and there's been several cycles around it in the past. Federation essentially means at a high level that you have one engine that can talk to multiple data sources and databases, query, and then aggregate those results back. Sometimes it might be a query just to one system, and sometimes there might be a join across multiple systems. And the first federated databases, FDBMSs, started, papers were written in 1985. The next round of it happened in the early 2000s with the software, like startups like Composite was acquired by Cisco. There was a federation paper written by Laura Haas. She's an IBM fellow in the database space. was called the Garlic paper, that introduced that introduced federation, and then that got absorbed into DB2 federation. It became over time DB2 federation. But really, what changed the game was the cloud and the big data space, because from the 90s and 2000s, where data warehouses were really the place where data landed. It was the star schema, the snowflake schema was the schema, right? That was the governed schema that that was the version of truth for all data. That began to change. With the introduction of MapReduce, Spark, a lot more databases, NoSQL, many things changed. So data started to end up in many different places, oftentimes file systems, not even databases. And in addition to that, the schema was spread across. There was not one Uber system with schema for everything. And so that's when early 2010s, Federation kind of had a big comeback. There were several papers that came out of it. Presto was created by Facebook and open source in 2013. And since then, it's basically taken off. And if you look at this disaggregated stack of storage and compute, you will see that over the next 10, 15 years, there is really a need for a new architecture, because it's very different from the database world that we've been in for the last 50. So Presto is widely used already at many different companies, largely internet companies, because that's they're the ones who kind of break through and need the scale, oftentimes, which does not come with the existing systems. But there were specific business needs for it. So data-driven decision making is obviously increasing. It's every decision increasingly needs to be data-driven, which means that there needs to be technology that enables that. In also businesses, data analysts, product marketers, product managers need more and more data to iterate over. On the technology side, there is a huge disaggregation of storage and compute trend that's happening, where increasingly data is ending in data lakes. And so you need a separate compute engine that utilizes and so runs on top of these data lakes. That can process data at large scale, as well as be very flexible with how it can handle data. So what is Presto? So Presto is a distributed, fundamentally, it's a distributed SQL query engine. It's ANSI SQL compliant, and so it can run on databases or data lakes. And if you think of the old database stack, you have parser, compiler, query rewrite, optimizer, execution engine, and then typically you had the storage and indexing aspects of it right underneath that, perhaps a buffer pool, table spaces, etc. That piece of it is now in the storage tier, and the execution engine is where Presto stops at, right? And so at that point, it pushes some aspects of it down to the databases underneath it, or the data systems underneath it, pulls the data it needs into Presto itself to give back results to the user. It's designed to be interactive, which means that it's an in-memory system designed to be very fast. We'll talk a little bit about it a little bit later. And it's highly scalable. So it's built out as a scalable shared nothing architecture to be able to access large amounts of data. So petabytes of data. It's running at large scale at Facebook, Uber, Twitter, many places. So it is open source. You can go ahead and take a look at the GitHub project if you're interested in contributing. I am also the chair of the Presto Foundation outreach team, and work very closely with the foundation that's a part of Linux Foundation that hosts the project. And I would recommend folks to contribute and take a look, get started, join the Slack channel, and ask for help if needed, and get going. So Presto is, in terms of the architecture, you see here that you have one coordinator and many workers. On the top, you have a pretty standard database interface. So you have JDBC, ODBC drivers to connect to BI tools. It could be Looker, it could be Tableau, Superset, increasingly notebooks like Jupyter Zeppelin. and other tools, right? On the bottom, you have a pluggable interface that Presto provides. And so there are many connectors that exist that allow you to query the data that's sitting in a range of different systems. It could be more traditional relational systems like SQL Server, MySQL, Postgres. It could be NoSQL databases like Mongo, Cassandra, caches like Redis, real-time systems like Druid, Pinot, etc., that are up and coming, as well as data lakes, which are file systems or object stores. So HDFS, for example, or S3. So at this point, you might want to ask, so you said it supports SQL. Is it really a database, right? And so the answer to that, in my perspective, is it's more like a database of databases because it sits on top of many different data systems, and it does not actually manage the data directly, right? So it's really a query engine that is allowing users to access data from these different systems, pulling it into one system and giving that abstraction, providing that abstraction to users. Typically, a platform team is tasked with making all this data accessible to their analysts, etc. And so either they can pipeline the data, copy it from various systems, pipe it into one system, or make multiple copies of it in different systems, and then integrate every single layer tool we saw on the top with every system on the bottom, right? And it gets pretty complicated. Pipelining can get very expensive. And so that's, in one way, that's one of the biggest problems it solves, where it queries data in place, meaning you don't need to move it from one system to another. You can query it where it is in place, and get results back for the end user. The second question you may ask is, how is this related with Hadoop? Some things are sounding kind of familiar with the Hadoop side. Some things are sounding familiar with the SQL database side of the house. Now, Presto evolved as a replacement for Hive, and I have a chart that's next, which kind of shows, how people might deploy Presto along with other engines. And because it kind of came out of the Hadoop ecosystem, there are some aspects that Presto depends on from the Hadoop ecosystem. For example, it does not come with its own catalog that you could use. And so it depends on catalogs outside Presto. For example, the Hive Metastore, which is a very popular one that came out of the Hadoop ecosystem. And so the metadata for S3 or HDFS may be stored in the Hive Metastore. And it depends on this to actually run the queries, because data is only as good as your metadata. And so you need to pull in the metadata from somewhere, so you know the schema, you know the databases, you know the tables, columns, everything underneath it. So there are some aspects that it does, has absorbed from a Hadoop. There's also the shared nothing distributed architecture, which is similar to the other query engines. But apart from that, a lot of the other aspects from a user perspective are like a database, right? And so the JDBC interface, the SQL syntax, for example, all of those aspects are more like a database. And then related to that is it different from a data warehouse? And so Presto, as I mentioned earlier, doesn't manage the data itself. Typically, a data warehouse is a fully integrated stack that you have to ingest the data into, right? So if you use a Teradata, Vertica, or Snowflake, you have to ingest all your data into the system before you can query it. But with Presto, you don't have to do that. You can query in place. All right. Shala, feel free to stop me if there's any questions on the chat. I'm not monitoring that. So if there's something that's relevant.
There is one question on the chat window. How is Ohana offering different from a Starburst offering?
Okay, good question. So Ohana is focused on is focused on Presto DB. Presto at the moment has a couple of different repos projects. There's the original one that Facebook open sourced, that's a part of the Linux Foundation. And that's the one that we are supporting, that we're building on. And that is different from Starburst, which is essentially a slightly different repo. It's based on another repo. Starburst is also an enterprise kind of a proprietary distribution. And they have kind of their own capabilities. Ohana is focused mostly also on the cloud, and that's the area that we're looking at, and we're involved with the community. I'll talk a little bit about our AMIs and sandboxes that we have, and so we have tools, offerings that allow users to get started easily with PrestoDB. All right. So in terms of a deployment, this is what a typical deployment may look like at some of these internet companies. You have a front end of Tableau, Zeppelin, etc. via JDBC, maybe some visualization along with that. Typically, Presto is now a de facto standard for SQL analytics. So ad hoc analytics, interactive analytics, and Hive is the previous generation of, it's a batch, it's more a batch processing tool engine, and then Spark SQL is typically used for ETL jobs or data pipelining, data wrangling, those kind of use cases. We are seeing increasingly more use cases with Presto itself, so including A/B testing. There's a paper that I have a reference here later on, where Facebook shares how it's running some of these use cases, A/B testing, ETL jobs, etc. And then underneath it, many times you have the Hive Meta Store that I was talking about earlier, that essentially serves as a catalog for the systems, that the data lakes that sit underneath it. HDFS, S3, GCS, etc. For relational databases, if you have MySQL or a SQL server, Presto directly connects via JDBC to those systems underneath and uses the catalog from those systems to pull the metadata information in, and based on the metadata information, the data as well. All right, so let's move on to what is what makes Presto a little bit different. There's three, I would say, key aspects of it. Very scalable architecture. We'll take a look at that. A flexible, pluggable connector interface. You could build any connector for Presto because it exposes a very nice interface. It's called an SPI, that you could build not just connectors to data sources, but also for logging or eventing, and etc. And the entire interface or security plugins, it's highly pluggable. And the third one is performance. Given that it's an in-memory system, it's highly performant compared with the previous generations. So let's take a look at the architecture. So the Presto itself has two kinds of nodes. Sometimes people call it server types or just node types. The primary one is the coordinator, and you have then a set of workers. You can scale up Presto, extremely widely, depending obviously on your hardware, on your sizing of your requirements. The coordinator is what the tools would interface with, and user tools via JDBC would connect to they would be clients. Clients would connect to the coordinator, and then the coordinator sees, okay, I have 10 workers, or I have 20 workers, or I have 100 workers, or I have 1,000 workers, and distributes work across those effectively, which then each worker talks to the data source that it needs to access for small parts of the data, and hence it can do large amounts of work because of the scale out architecture. So if you look one level deeper within the coordinator and within the workers, etc., as I mentioned, you have the clients on the top. The SQL comes in. There's to the parser analyzer. in some cases may need to talk to the metadata API. The metadata essentially will get pulled in from either Hive Meta Store or the catalogs, the data sources that you have connected into Presto, integrated into Presto. And then it goes into the planner. Planner is essentially the database optimizer, which then schedules out that query. To schedule, you look at the data location, which means how is this data spread across, and how can I execute this split it into multiple different jobs, and they're called splits. And so you essentially have multiple splits that then run on the workers underneath, that connect to via the connectors to a range of different sources that sit underneath it. Now, there are obviously times where you might want to do joins or things that need cross data across workers. That's called a shuffle in the kind of Hadoop terminology. And so you may need to do, a shuffle across workers depending on the query and depending on the plan. As I was mentioning earlier, Presto has an extremely pluggable interface, and everything essentially is a plugin to Presto. Here I just show kind of a set of connectors that that are the popular ones. I think actually S3 is missing. So the way that you connect to data lakes, and when I say data lakes, essentially I mean data file systems as well as object stores, is a little bit different than the way you would connect to databases that already have a catalog that's built in. And that's because the metadata and the data are together for databases, versus for data lakes, the metadata is not with the data in many cases. And so the Hive connector is what is used, and I'll talk a little bit about it in the next few slides, to query data lakes. And then for each of the other databases, there's individual connectors. So you have a Presto SQL connector that can allow you to connect, attach databases in Postgres. For Redis, there's one for Elastic, etc., MySQL. And each connector is a little bit different. As you can imagine, some of these have relational data in it, tabular data. Some of these have JSON in it, right? And so each connector essentially defines an API that allows you to transform, if it's non-relational, some way of flattening or some way of understanding or mapping that underlying a semi-structured format to a tabular format. So once it's in Presto, essentially everything is tabular. And in that point, it's functioning as a traditional SQL engine would, assuming that there are tables have columns have rows, there could be aggregates across those, there could be filters, predicates across those in queries, etc. So the connector itself, when you install Presto, you have to go in and connect, set up, configure each connector, and typically for every type of data source, you would have a catalog.properties file that you go into, and you essentially provide the JDBC endpoint. In some cases, maybe access privileges that you would need for Presto to access these details. And as I was mentioning, there's a range of there's probably close to 40 connectors that Presto has across different databases and data sources. The catalog, as I was mentioning, is it's the schema from the data source itself. Either it will come from catalogs like Hive Meta Store or AWS Glue if you're running in the cloud, or from the database itself. Schemas are essentially namespaces organized into tables, and then tables are an unordered set of rows with columns with specific types associated with those columns, which obviously make impact the way that they are processed. So let's take a look at the Hive connector, which is the most popular.
I'm sorry,
Yeah,
Dipti. There is question. Let me just interrupt you right here. So before we move forward. So the question is, how is Ohana, I assume they mean Presto, compared to execution engines native to data warehouses such as Snowflake?
Yeah, yeah, it's a good question. it is, at the end of the day, Presto essentially is a SQL query engine, right? And so from all the aspects of of a SQL query engine that you would be aware of, they are implemented in some level or some at some level within Presto, right? So there are a couple of ways of optimizing. There's a rule-based optimizer where you can give hints. There's also a cost-based optimizer, but that relies on stats. And stats, you may or may not have stats in your data lake. And so in some ways, the architecture is similar to what you would expect in a data warehouse. However, because it's built for data lakes as well, it is a lot more flexible with that, and there are certain things that you can configure because you may not have stats. And so you may not be able to use a cost-based optimizer. You have to use a rules-based optimizer. But as we start, as the project evolves, essentially there is a lot of learnings from databases that will be directly applied to Presto with all the standard enhancements that you would expect, right? Join reordering, for example, or predicate pushdowns, for example. Some of the connectors already have some of these capabilities. And so the fundamental while the stack kind of looks the same, the fundamental difference from a data warehouse is that it does not manage the data, and so it always pushes down as far as it can via the connectors to pull data in, to push down the predicates, or push down the get partial aggregates directly from the system underneath as much as it can, and then get it into memory and process it in that way. So the storage tier is completely different. The top part of the stack is similar, and in conceptually it's similar, but it's slightly different, given that you could run on data lakes. For example, Presto by default, if you use the Hive connector, uses the ORC format to store data. ORC format, it's a very popular format. You can also use Parquet format. And there's multiple different formats that can be supported, which may not be the case with a traditional data warehouse. You would have to transform that into, ingest the data into the data warehouse and store it in whatever the proprietary format is that they use that you don't have visibility into. So Presto is really good at trying to leverage the raw formats that you already have, and in some cases even optimize them.
Okay. Now that interrupted you, let me just ask one more question. How is Presto different from Hive?
Yeah, so Hive was the first generation of SQL on Hadoop, right? And it was built as a batch engine. Hive has a couple of different implementations underneath it. So there's a Hive query language, and then you could do Hive on MapReduce, or Hive on some other engines, Hive on Tez, etc. But they were built to be batch oriented. And so with Presto, given that it's a fully in-memory engine, it is meant to be interactive. And so speed-wise, we have seen orders of magnitude difference as users have deployed them. In some cases, Presto may be 15 times faster than 15 to 20 times faster than Hive, right? Because of the architectural differences. All right, let's keep going. So I think I talked a little bit about the Hive connector. Access, obviously, security becomes very important. At the end of the day, it's touching data. And so there are many different authentication, authorization models that Presto supports. You could use, in the Hadoop world, impersonation is pretty common. And so you basically pass down the user with the assumption that it's authenticated on the top, with you using LDAP, something like that along those lines. Authorization is available either in a file-based authorization approach, or a SQL-based authorization approach if data is, if the catalog is in a Hive metastore, where you can actually say grant, revoke, right, reads or writes on specific tables, etc. And then if it has access, obviously at the connector level, then it will be able to reach into the data source and in these cases data lakes, and get that data back out. I was just mentioning that it supports different file systems. So the by default, it's ORC. Facebook uses ORC very widely. Parquet is another structured format that for for raw data that's sitting in data lakes, that's also very popular. Both these essentially have some metadata that's a part of the file itself in the footer, which will essentially have some metadata information, in some cases some aggregates that Presto relies on. So it understands a range of these formats, Avro, JSON, text, etc. And all of this is without ingestion. So you can essentially point Presto to an external data source. So you can essentially say create table, and it's an external table. The format is whatever your file format is in your data lake. And it'll understand that. It will use the appropriate reader for it, a Parquet reader or an ORC reader, etc., and then create that table as an external table in Hive. You can create internal tables as well if your catalog is set up with configured with a data with a bucket, an S3 bucket, or a data lake folder underneath it. Another example for real-time analytics is Druid. There are a couple of popular engines that are coming up like Pinot, Druid, that are meant for real-time analytics in the kind of this new modern disaggregated world. And so in this case, it uses a SQL JDBC connector because it's essentially a database. And so it just would use the JDBC connector at the bottom, connect to it, and then you can do cross data source joins across Druid or MySQL or whatever the data sources across all these different data sources. All right, before getting into why Presto, I see one more question, and it'll be good. It's a good segue actually into the next section. So, how is Presto different from Apache Spark? So Spark was built as a general purpose query engine, right? Like MapReduce is something like, it's not related with databases, right? It's not related to structured data. MapReduce is a format, a framework that you can process anything, be it files, be it images, be it, various different things, right? And so SQL was the next generation of MapReduce in some ways, that was highly reliable, very fault tolerant, but it was built as a general purpose compute engine. So you can do many, many things with Spark. Uses RDDs internally as the file format, etc. It is typically very effective and very what it's good at is transformations, moving data, pipelining, so ETL type of workloads. And then on top of Apache Spark, they added Spark SQL. So they threw a SQL layer on top of a general purpose computational engine to then try to support SQL workloads, structured workloads. And so Hive was the first generation. Spark SQL became kind of the next generation. But because it was built on top of a general purpose engine, it is built for it. It's not as good for these interactive querying or ad hoc querying use cases, but it's good for the transformation use cases. And in addition, it's not all in memory, which means that stage to stage, it actually persists data, even for a single query. So a single query is broken down into stages. And so within a query itself, it will persist data and then read it back in for the next stage. This is obviously very good for fault tolerance and ETL type of workloads. But if you just want to run query and get results like a data warehouse, then that's very expensive. And that's where Presto comes in, where it is fully in memory. It has a split to disk option, but most people just run it in memory to get the fastest performance. And that's how it's different from Apache Spark. So let's actually, so that's one of the reasons it's fast. It's a pull model where it pulls data from it. It tries to reduce the cardinality of the data sets that it's pulling in by pushing down as much as possible. and some connectors have more push downs than others, and over time they will all be as advanced or as as powerful enough that any filter, any projection, any aggregate that can be pushed down to get that a smaller result set back, that would be applied, and that's where the project is headed. And so it once it pulls that in, everything comes into memory. It's streamed in. It's streamed into memory, and then you have grouped execution that runs within memory. It uses the columnar storage, so org, parquet. These are all columnar kind of file formats, and for the execution. All right, so the life of a query, it's kind of similar to, at the end of the day, SQL is SQL. That's the beauty of it, right? 50 years later, a select star from table where it looks pretty much the same. It's just that the engine has changed underneath it. You drive a car, you have a round steering wheel. It could be a fully electric engine, or it could be a gas guzzler, right? So with Presto, it's you're getting a fully electric engine in some ways, where it's really fast, and you would essentially scan order stable, right? You would filter on the discount predicate, and then you essentially output that back to the coordinator. So the workers perform some of these tasks. So the scan will be split across all the workers. So you're scanning different parts of the table, right? Across different workers, and then that gets pulled in, and then you filter it, and then you send it back to the coordinator. The coordinator groups all the results together and returns it back to the client on a per session basis. Now, in some cases, you may be able to push this filter predicate down to the connector and say, hey, don't just do a table scan and send me all that, that's 1980s. Let just send me the matching rows where the predicate is already matched. And so it allows the beauty of Presto is allows the system underneath to take on some of that work, right? And that is important because the way that technology is deployed today is very different. A lot of it is in the cloud. A lot of it is highly elastic, which means that your systems underneath are very powerful. RDS on AWS can give you as much throughput as you need. And so if you can push down to some of these systems, use the power of the cloud and the flexibility and the elasticity of it, you can then, you're able to access and churn and process a lot more data and at good speeds, because you're able to use the infrastructure underneath it. This is a slightly more complicated query. You have an aggregate, so you have a sum, and then you have a left outer join, a left join on line items, and then you have the order key. You have a where clause again, and then you have a group by, right? And so the plan will look, these are logical plans, look a little bit different. You have a scan on one side, a filter on it, then you have the join on the other table, which is the orders table, and you obviously want to have as few rows on the outside, and then you go in and join on the right side, and then you get the aggregate back out. In some cases, if the aggregate can be pushed down all the way down, the optimizer, the planner will try to do that. So okay, you're telling me Presto is awesome, and what are the gotchas, right? So there it is an in-memory system. There is a spill to disk mechanism, but essentially, if you want to get that speed, you are memory limited. Now, increasingly, it's becoming easier to just scale out and add nodes. You have auto scale groups and AWS and other clouds, etc. But that is a limitation you would have to kind of think about. Size your cluster for, right? Fault tolerance. Because it's a distributed system, and some of your queries can be touching a lot of data. And on a per query basis, if a worker goes down, and you may it affects the entire query, and so you have query failures if individual workers go down. And so that is an area of the project that people are looking at to improve fault tolerance, etc. And then the third one is it is a single coordinator, and so if you need HA, you have to manually do this if you're deploying it yourself. have multiple coordinators, have an HA proxy on top. And so it gets a little bit complicated. It would be really nice if the system just had that capability within it. And this is also an area that, that folks are working on. So I think we're at 9:50. I want to see if there's any other questions. But in terms of a good place to start, as I mentioned earlier, Ohana, it can be quite complicated to go download the tarball and get all this set up on your own. And so what we've done to make it easy is we have a Docker image as well as a sandbox, AMI if you're on AWS. To get started, and we'll share, I think you'll have the recording available, and we'll try to share these links. Actually, I could post it into the chat here if anyone's interested, and that would be a good place to start. You just do a Docker. Let me see if I have the tutorial available. I could, yeah. So this is the sandbox for Docker. I think. Do you see the Docker sandbox on the screen? Okay. And so it comes pre-integrated, for example, with TPCDS, TPCH connectors. And so you could just get started with a Docker run, get the Presto server up, and then you start off the Presto CLI, which is essentially like a SQL client. And you can run some commands. You see which catalogs are available. You can attach to a specific catalog, and then you can start querying it. These are, TPCDS. These are scale factors. So you can pick a particular catalog, or you could even start. You could do it like this: use TPCDS scale factor 10, or you could start your Presto client itself using a specific schema. Yeah, and so that's that might be a good place to start for you if you're just getting started. So Ohana, a little bit about Ohana. We are a PrestoDB company. We're a part of the Linux Foundation, as I mentioned. We're a startup backed by Google Ventures, and we were just we're excited about being listed as top 10 big data startup of 2020. And as a part of my other job, which is chair of the Presto Foundation and volunteering with the Linux Foundation, we have a special discount for women in big data members and for you folks who are on today. And I think Shala may send out a follow-up after this. But that's the code right here. If you use the code, it's completely free for you to attend. It's an all-day event. It's the biggest Presto event of the year. We have Facebook, Uber, Twitter, speakers, creators of Superset, etc. There will be panel discussions. So hope you can join folks and learn more about Presto and a little bit more about joining the community as well, and staying up to date with Hana. So with that, I'm going to open it up for Q&A. And if you're asking if you're hiring, yes, we are. We are hiring, and we'll find a way to get you folks talking with us. All right, Shala, back to you.
So there is one question in the chat window.
Okay.
What predicates and computations Presto can push down to connector level? What predicates and computation?
Yeah, good question. Right now, it depends on, it's on a connector to connector basis. The more advanced connectors can do more advanced predicate push down, filters, most certainly, in some cases, aggregates, partial aggregates. It really varies by the connector. And so the work that we are doing with open source, as an example, is to improve some of that and actually advance it even further, to try to have more advanced connectors for the popular databases, as well as try to ship more operators down if possible. You essentially have to generate the query language for the database underneath, right? And execute it then on that engine underneath it. Yeah. So hopefully that answers your question.
Any other questions? Anyone, you can unmute and ask the question if you wish. While waiting for another minute or two for anyone else to ask questions, is there a roadmap, Dipti, for the Presto? I know you
Yeah.
mentioned few areas that still needs to be worked, but is there a formal roadmap?
Yeah, good question. Open source projects are very interesting. Many times the community kind of determines what those are. So if you go to the GitHub project, you can essentially see, what the open PRs are. What are, there's some that are more important than others that are tracked on a wiki or marked, tagged as roadmap. Um, Good ones, as I mentioned, big ones are the single coordinator. Reliability, relying on a single coordinator. That's a big one. And then there's others, right? Like adding SSL TLS support to some specific connector. That's kind of more specific. That's particular to some user who's using that. So all of this is public and open, and so it's basically getting involved with the community, taking a look at the GitHub tickets and PRs, and maybe contributing back in.
How big is the community? The
It
Presto
is,
country, yeah.
yeah, it's a fairly large. I mean, as I was showing earlier, right? There's many companies that are contributing back in. It varies by, some do a lot, some are focused on specific areas of interest, and there's thousands of folks on the Slack channel, for example, and so on.
Wow. Okay. Okay. Very nice.
All
I don't see
right.
any other question. Yeah, go ahead. Last opportunity for any questions. If not, any closing? There is one question. Are there any known providers of Presto as service?
Yeah, good question. So at the moment, Presto is available. So AWS has a couple of services that, if you're in AWS, you could try to use. EMR, for example, has the option to use Presto. And EMR is AWS's version of Hadoop in a box, right? So if you could try that, out. They have another one called Athena, which is maybe useful depending on your use case. It's a serverless model, so it's query by query at a time. But if you want to deploy it as a cluster, then EMR. And those are more popular ones. All right, Shala, I think with that, let's wrap up. And thank you again for having me here. And feel free to reach out to me for questions. I'm Dipti at ohana.io, and happy to engage with in whichever way needed, either to answer big data questions, career questions, get you to your next distributed systems job, or introduce you to someone that I may know. Thanks, everyone.
Thank you. Thank you. That was really a pleasure. Thank you, everyone, for participating and good questions. Talk to you next time. Bye-bye.
Cheers. Bye-bye.